Hi folks, my name is John and I'm a dev focusing on procedural generation. And one of the things that I've had as a goal for a while is to simulate biological motion using some procedural method. And I wanted to give an update on my approaches to that goal so far. So in this implementation, I have here a limb that's composed of a series of joints in white, which are connected by these dotted white lines, and that limb is procedurally generated, and then its goal is set to try to touch this gray sphere here outlined in orange, and its touch at the point of that gray sphere is supposed to be in alignment with that blue forward of that gray sphere there. So this is what the limb simulation has trained up procedurally, and it does a pretty good job of moving the terminal node of this limb to touch that gray sphere. So I'm going to turn training on and then show you some of the capabilities of this process. So let's say instead that I want to approach that gray sphere and have the touch occur and point out in that direction. So right now we have really jerky training motion going on right now, but soon we'll be able to see. I think it's close enough right now. So let's turn off training. And so this limb has dynamically trained itself to touch that sphere in its new position and in that new direction. And another thing is that we can train multiple limbs at the same, or multiple animations at the same time. So let's say that I also want to train to touch that position there. Well, it's going to train up. And the training will take a little while, but yeah, that doesn't really look right. So we'll have to wait some more. Okay, close enough. So you can see that the blue forward of this line is mostly, the blue forward here of the sphere is mostly in line with the motion of the limb that's been simulated and trained up in real time. So let's do one more training. Let's say that I want to have this limb touch its own belly button or something like that. So so this is the origin of the limb, and I'm going to put this third sphere right at the same position and turn on training. And the limb is going to train to give itself belly button scratch. That's close enough, I think. So these animations can be trained up really quickly. I think that that's good enough, sort of a pinching motion. So right now there is no limb collision, and the joints are hyper flexible. That is, that they can rotate to any degree necessary in order to reach their target. I'm going to incorporate constraints on these limbs so that there's only a certain amount of rotation that they can give, and that'll serve to make the motion look more biologically plausible, and it'll also address issues with the limb collision as is occurring right now. Okay, so let's go over, well, let's give an overview of the solution. So right now I'm building these animations using keyframes between this position here, you see, and that position there. And then we were just using an interpolation between any of these animations. Let's look at another one. So for example, this is another pair of keyframes, like one here, 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 to there, that touch point. And this limb is trained using a very basic optimization of error. I'm just selecting the choice with the lower error, and error is quantified as being distance to the specified touch point, and also the dot product of the current vector of motion of the last node compared to with respect to the forward of the touch point specified. So in the future, I'm going to move from training using that dot product of alignment to instead simulation of levers for each individual joint in this limb, and then I'm going to train for a force to be produced by those levers instead of training for a dot product being aligned. And the path toward that is well, getting there will be a process, but the process will be straightforward. The actual implementation, I don't know, it's going to take a while, but that's going to be the next phase of this process.